So we've talked about solar interactions with Earth. What about the rest of the solar system or beyond? Um, Solar magnetosphere is the region of space where the sun's magnetic field and solar wind dominate. And it's separate from the interstellar medium. The interstellar medium is the space between stars. The magnetosphere, in some sense, the solar domain here, in some sense, is the solar system. So the heliosphere is the term that's used to describe the region of space where the sun dominates. And so what happens is the solar wind starts moving outwards here. The solar magnetic field dominates outside of the heliosphere. Then you've got the interstellar gases. We have the interstellar medium, and that actually moves a little bit relative to the solar system, and so we call that the interstellar wind. And so what happens though is as the solar wind is moving outwards, it eventually reaches a point where it starts slowing down and building up a little bit. So that means you have a region of space out here where you have an increase in particles. And we call that the solar wind termination shock. Likewise, the interstellar particles will kind of run into the edge of the heliosphere and start flowing around it. So you have a region out here where you have a buildup of solar wind particles, and we call that the bow shock. And so the actual dividing line between where the sun's magnetic field and the solar wind dominates and the interstellar medium and the intergalactic magnetic field dominates is called the Heliopause. So that's really the boundary of the sun's magnetodomain. And so it exists between the solar wind termination shock and the heliopause. Actually, between the whole solar wind termination shock and the bow shock, there's a voltage differential. And that voltage differential can actually act as a particle accelerator and hurl particles in or out of the solar system. So right now, there's actually several spacecraft that have been launched from Earth on trajectories that are leading outside of the solar system. There's actually five of them. Two of them, the Pioneer 10, Pioneer 11 spacecraft, no longer operate. Voyagers 1 and 2 barely operate because they left in the 1970s. It's been a very long time, and they use plutonium as it decays, it produces a little bit of heat, produces electricity, and the plutonium is radioactive, it decays, and there's less of it, and so the amount of electricity being produced is gradually dropping. Um, so they're starting to have issues out there. One other, the New Horizons, is on its way out, but it has not yet left the solar system. Voyager 1 and Voyager 2 have actually reached the heliopause, and so they have started to move into interstellar space. One of them is actually on the way real close to the bow shock, and so it's about to move into pure unaltered interstellar space and give us our first glimpse of what's out there. So they are on the way out right now, and they are about to give us a true measure of what's beyond our solar system, a true measure of interstellar space. If they continue working, they are very close to the end of their life, and if Congress does not decide to cut the project, because they've actually shut down some of the receiving stations that were used to pick up these signals. And one of the last remaining receiving stations is now going to be shut down for an upgrade. And so when it comes back online, if it comes back online, then we'll see if we're getting data from the spacecraft. So with that, that ends our saga in terms of the sun as the sun behaves. Our next topic is going to be, how does the sun die? Because it's not going to keep fusing and doing what it's doing forever. It will eventually die, and so that's going to have dramatic impact on Earth, obviously. And so we want to know, how does the sun die? So that's our very next topic.